This building was really the conception of David Fisher as he was creating the new Sustainable Living program. And he wanted a building that would completely honor sustainable living, which is to say that it would be built of local materials as much as possible, built with an extremely low carbon footprint, would be made of natural materials, would be a building that would teach the students, that there would actually be things about the physical structure of the building that could be used to teach sustainable living to the students. The design that David and I came up with initially then got overlaid by a series of bodies of information that we learned or were inspired by from speakers at successive eco-fairs that were organized by students here. I'd known about daylighting and I'd understood the benefits of it, that it greatly reduces the amount of electricity needed to operate a building and also creates greatly superior environment in which to study or live one's life within a more of nature's own environment, which includes illumination directly by the sun. And we were successful when the sun is out on any bright day. All of the rooms in this building get enough daylight in them that you don't have to have lights on. And the construction drawings of this building were created such that it was assumed that the walls would almost entirely be made of blocks of earth compressed from the site. So we rented a pneumatic earth block pressing machine from a company in Wisconsin. It was here for a summer, and students stayed over the summer and operated the machine and made about 25,000 earth blocks. Another speaker spoke about earth plasters, and so these blocks were then plastered with earth from this site, because again, with high clay content, the earth could be easily, with just a couple of things added, cow manure or straw, could become a really good base plaster. And then at another eco-fair, a wonderful architect from Wisconsin named Roel Gunderson spoke in a very passionate way to build buildings primarily using trees, but keeping the trunk of the tree as the trunk of a tree. And he speaks about the advantages of this. One is that the wood is much stronger structurally. Trees grow as concentric rings of new growth each year. And each of these rings has a certain amount of structural strength. And when you slice a trunk of a tree to make a 2x4 or a 2x6, you lose the particular geometric strength of the circle. My thought then was that this central corridor that we are standing in should be lined by tree trunks, which then could become really structural, not ornamental, because the high roof over this central corridor, which is lifted up above the roof of the rest of the building so that we can have clear-story lights, windows high, that bring sunlight in from the south and from the north into the very heart of the building. And so my idea was that at the heart of the building, that where we have this pattern from Vastu of the Brahmastan, nature with a small n should also be very present. We have created a grove of trees, a copse, a little piece of nature in the center of a building. In this room, the entire west wall and also a band of blocks on two of the other walls are the earth blocks themselves. And so you can touch them, you can see them. They're dry laid, that is, there's no mortar between them. In this building, the lights are in little 2-foot by 4-foot panels, which are called troffers, and they look sort of vaguely in our mind's eye like conventional fluorescent troffers that we see in most commercial or educational buildings. But in fact, these are LED lights, light-emitting diodes, which environmentally are much superior, and the quality of the light we consider to be superior, and which have reduced electromagnetic radiation. And so in 3 counts, they are superior. They also last frequently for 20 years. And the power for them is provided through battery storage, which batteries are charged by photovoltaic electric panels on the roof of this building and on its annex, and by a wind generator. And so while this building at this point in time is hooked up to the electric grid, it almost never in the course of its life will actually need to take any electricity from the electric grid. Typically, in these first weeks of its operation, at any given point in time, while the sun is out, it has been generating between 5 and 50 times as much electricity as it has been using. And the rest of the electricity that it's using is going to power the other buildings on the MUM campus. The windows are extremely thermally efficient. They are the most thermally efficient windows made in the US, at least at the time that we ordered them, with an R of 10. The benefit of east light, it is ideal to get sunlight from all directions into a building, as this and most buildings do. There's a particular benefit to east light. That benefit occurs around sunrise. For daylighting a building, the most valuable light is south light, but also, paradoxically, north light. North light, as many of you know, is highly valued because it's even light. There are several things that we have as goals for this building which we have not yet executed. And we have as an intention that the water used in this building will be completely supplied by rainwater, which is stored in rainwater catchment. So thank you very much for coming. It was nice to share it with you.